Hi, pre-cal honors. So we're going to do an example today from section 6.3, the famous baseball example. So we have a baseball player, and he hits a ball with an initial velocity of 130 feet per second from an initial height of 4 feet at an angle of 25 degrees with the horizontal. There is a 25-foot fence that is 350 feet from home plate. Will the hit be a home run? Well, let's see. So first of all, we know that distance equals rate times time. And we also know that the projectile motion formula is going to tell us the height of the ball with respect to time, where t is time, initial velocity is v naught, and s naught is initial height. So again, that's the projectile motion formula. So if we think about the ball, okay, it's hit at an angle of 25 degrees with the horizontal, and the initial velocity is 130 feet per second. But again, we're asking how high did the ball go? How far did it go? We're thinking about distances. So rate times time is the distance. And if I want the horizontal and vertical components of the ball, I could find that. So I know that we could write a parametric equation that x, the horizontal component of the ball, is 130t cos 25. And again, why I use this the formula for projectile motion, because again, gravity affects the vertical component of the path of the ball. It does not affect the horizontal. So we have 130t sine 25 minus 16t squared and plus 4 at the initial height, because again, we're not golfing. This is a baseball, and it was hit with an initial height of 4. So what we're going to do now is we're going to go ahead and just look at the calculator simulation. So I went ahead and went to mode and make sure I was in parametric mode and degree mode. I went down to sequential instead of simultaneous because I would like to build the fence before the ball is hit. So for the fence, it's 350 feet away. Now, I believe last time, the last example, I decided that 5 seconds made sense for the simulation. So for the y, again, there are a lot of ways you could describe the y component for the fence. I did, last time, I believe I did 5t if it's a 25-foot fence, because then it will go 5 times t, it will be a line. So the fence will actually be 25 feet high. That's not the only way you could have done it. For example, I could also say 25 minus 5t, and that would also build a vertical line that would be 25 feet high. Because think about it. After 1 second, if I'm thinking about the y component, I would have 20, let's do 0 seconds. 0 seconds, I would have a point at 25. 1 second, 25 minus 5 is 20. 2 seconds, etc. So notice it would start at 25 and build a vertical line. So that also works. So why don't we try that one, do something a little different this time. So here's our calculator. I went to window, and again, 0 to 5 seconds sounded good. T-step, that again could be a lot of different things. 0.05 made sense for as far as we don't want it to go too slow or too fast. We could always adjust that later if we don't like the speed. 375, I wanted to be at least 350 so we could see our fence. And I'm not sure how high the ball goes. I didn't find that algebraically yet, but I'm guessing 110 feet should be high enough. We went to y equals. So here's the fence, 350 feet away. And again, I had to put minus 10t. That works too. Okay. Again, we're going to build a fence. Now the initial velocity was 130. And so I have my x and my y equations there. Let's take a look at the graph. Oh, let's make it a baseball. Oh, it is a baseball. Okay, so here goes. Here's our fence, and here's the ball. Now, it's really hard to tell. It looks like it made it, but I'm not really sure. We need some algebra just to make sure. But again, I wanted to show you one more thing. If we go to y equals, and let's say for that fence, I made this 25 minus t. Can you guess what's going to happen? If I just said 25 minus t, let's see what happens. Notice that the fence, it stops there, because if I said 25 minus t, it would start at 25 and then it would go to 5 seconds, so it would stop at 20. What if I just made it 25? Then what would it look like? Let's take a look. If I made this, oops, y equals, if I made the fence the y equation. There we go. And if I just made it 25, watch what happens. See how it would just be a point, right? So that's why I did something like 25 minus 5t or 25 minus 10t. Okay, so let's do this, everyone. Let's take a look at the algebra now. For step 1, you want to let x be 350 and see what is t. How long did it, or how long did it take to reach the wall? So if x equals 350, what is the time? Okay, so solve this equation and you should get 2.97 seconds. Okay, so now step 2, I want to find out when it gets to the wall, how high is it? So when t is 2.97 seconds, because again, both x and y, the horizontal and vertical components of the path of the ball, they both depend on time. So now I'll use the y equation. So if we let t be 297, type it into your calculator, and you should get 2601. So that means it was a home run since the fence was 25 feet high, and it had 1.01 feet to spare. Home run. Great job.